we're going to find the moment required at the point D to keep the system in equilibrium whenever an input force of 25 pounds is pushed into the system at point A. So to do that, we're going to take the moment about D, the sum of all moments about D, and with that expression, we can solve for the moment, the required moment, to keep it at equilibrium. And first we're going to solve for unknown lengths in this free body diagram. So to start with, we're going to find the length BF, and that's going to be equal to 6 times the sine of 60, and that's going to be equal to 5.196 inches. And to find the length BE, that's going to be equal to 10 times the cosine of 60. And that will give us 5 inches. Next, we're going to get the length CF. And using Pythagorean's theorem, that's going to be equal to 6 squared minus 5.196 squared. And that's going to be equal to 3 inches. And next we're going to solve for the forces, the components of forces at the point C. So to find the y component of the force at point C, we see that the input force is only in the y direction, the negative y direction. So just by looking at the free body diagram, we can see that the y component of the force at point C is also going to be 25 in the opposite direction. So C of y is going to be equal to positive 25 pounds. And to solve for the x component, we need to take the moment about the B point. So we need to take the moment. So the sum of moments about B is equal to 0. And the formula for that is going to be 25 times BE minus CY times CF plus the x component of the force times BF. And set that equal to 0. So the only unknown in this expression is this x component that we're trying to solve for. Since we already found the y component, and we know we've already calculated the other lengths in this expression. So we plug in what we know, and that gives us 25 times 5 minus 25 times 3 plus c of x times 5.196 is equal to 0. And solving for that x component, we get a force of 38.5 pounds. And we can now take the moment about the sum of moments about B. So, and actually before doing that, we're going to solve for the length CG. So this length CG. So the length CG, that's going to be equal, so Pythagorean's theorem, it's going to be equal to 8 squared minus 3 squared, and that will give us 7.42 inches. And now we can take the sum of moments about the point D. So the sum of moments about the point D is equal to 0. And we can write that expression as negative C of x times CG minus c of y times dg plus the moment that we're trying to solve for, and set that equal to 0. So we know everything except for the c of x. So we plug in and solve for c of x. Moment. We know everything except for the moment. So we're solving for the moment. So negative cx, that was negative 38.5 times 7.42 minus 25 times 3 plus m is equal to 0. And solving for m, we get a value of 360.67 pounds inches.